This talk is about problem solutions and trade-offs. I'm going to talk about why solving problems is great, eliminating them is better, and avoiding them is even better if you can manage it. This talk is also going to be a little bit on the fast side, but I think that you all can manage that. This talk is not 100% about code. I do have a couple of code examples in here, but this is basically life principles. Here's what we're going to be learning. So let's get started. This is a problem tree. Problem trees are really scary, so I'm going to show you a simplified version. And I made this up. I don't know if anybody has like actual research on problem trees, but I'm going to explain what this is. So you have your core objective. That's what your business exists for. It's what you're trying to do that morning as you're getting up ready for the day. Whatever it is, you have something that you're trying to accomplish. And off of that is a problem that needs to be solved. That's what the lines are. They represent problems. And then each of these nodes are solutions to those problems. But sometimes your solution has other problems that you have to later deal with. And we're going to look at a couple of examples and ways that we can change this problem tree so that we have fewer and smaller problems to deal with. So just keep this in mind in the back of your mind as we go through this. First off, we need to establish the fact that we are problem solvers. That's the reason we're the dominant species on the planet, is because we are good at solving problems. And because we're so good at it, and it's actually pretty fun, we can sometimes also become problem seekers, where we're looking for problems to be solved, because it's a blast. It's super awesome. And I have a little story about this. When the pandemic started, my sister, who's an accomplished violinist, came to me and said, "Hey, Ken, I have this idea for an app." And of course she does, like everybody does. But she said, all of my friends who are musicians are totally out of work. I want to find a way for them to make money during this time. And so she basically wanted me to build Zoom, Google Calendar, and Tito in one app. And not just me, but she wanted me to find one of you people who would be willing to do that. She said, "I've got money, and we're going to make this a thing." And of course, like, we all know that even we underestimate the amount of effort that it takes to build like anything. And so I really advised her that what she should do is just use these tools, and her value proposition for her company would be that she would manually use these tools and facilitate this sort of teaching, instruction sort of thing she wanted for these musicians. And she didn't end up actually going through with the idea. She just got busy with other things. But it just was another reminder to me that it's really important, before you try to solve a problem, to understand what that problem is in the first place. We solve problems we don't understand all of the time. And so in general, I recommend that you try to avoid solving a problem until solving it is unavoidable. Recently, Elon Musk gave an interview where he said possibly the most common error of a smart engineer is to optimize the thing that should not exist. It is better to avoid problems than to solve them. And yeah, I felt like he was talking to me. Yes, I make this mistake all of the time, trying to solve problems that I don't need to be solved. So this is our problem tree, and this is what it looks like when you avoid a problem. You just cut off a whole bunch of the other problems and solutions. So here we have this solution 1B, and we decide, you know what, the problem that's stemming off right here, it doesn't need to be solved. We're just going to leave it unsolved. For now. And it's possible that in the future you could decide that you can come back and solve that problem again. But the key thing to remember, specifically about problem avoidance, isn't just that we just decide we're never going to solve this problem, but it's that we're prioritizing the problems that we're going to solve, because time is a zero-sum game. Every single one of these things and everything that you can spend your time doing is taking time away from other things that you could be spending your time doing. And so just keep that in mind as you're like down here on solution 1BBAB, and you're working on like this really, really complicated, hard thing. Maybe you could just stop and say, you know what, if I'd known how hard this would be to solve, I never would have tried in the first place. How many have felt like that before? Like, if I'd known, yeah, like most of us wouldn't even be here if we, no, just kidding. So when you're in that mode and you're like, man, this is not great, then think about that problem and wonder to yourself, like, does that problem need to be solved? And if your answer is, well, yeah, otherwise this solution won't work at all, well then think about the problem that thing is trying to solve, and ask yourself, does that need to be solved? And maybe it doesn't. Maybe, or maybe it's like a critical solution to this particular solution. And if you keep on going up in the problem tree, eventually you could find that there's actually an entire feature of your app that, or an entire portion of your day, something that you do throughout your day, that just doesn't need to be done. Or at least it doesn't need to be done right now, and you can focus your time elsewhere. Sometimes problems are unavoidable, though. I don't know how that house ended up there, but I hope they got it down, because that would be an unavoidable problem, I'd say. So in those situations, the next thing we should try is to eliminate the problem altogether. I guess the metaphor kind of isn't great, because that would be like blowing up the house or something. I don't know, but you want to try to eliminate the problem. So let me explain why. It's because solutions hold you captive to their maintenance for as long as they exist. And so the more, as fun as it is to build out solutions, the more solutions you build, the more captivated you are by those solutions. And you're constantly having to maintain those solutions. So you want to eliminate problems. So what does this look like in practice? This is an internal combustion engine. We've been working on these for 100 years, or more than 100 years, and we've gotten really good at it. And the internal combustion engine eliminated a lot of problems that we had with the horse and buggy. Smell, methane, like a lot of problems we had with horses. Distance, speed, so many things were eliminated when we started making cars. But there are a lot of problems that cars do have that we've kind of left unsolved. Exhaust is one. So the solution for exhaust is, because like you're literally taking gasoline and burning it, making explosions. There are explosions happening like 3 feet from your toes. Is anybody like, what? Like when you think about it, you're like, who made this? Who invented this idea? That's nuts. But we do it, and when you explode these things, there's some gas that, I guess it's gas technically, that comes out of that. We don't want that in the cabin. And so we put a bunch of piping and everything so that we spew it out the back of the car, where of course it will do no harm to anybody. That was sarcasm. So that part of the problem we have solved, but spewing things out the back of the car, that has not been solved. And we just decided we're not going to solve that problem. Stopping is also another problem. When you're moving at 70 miles an hour, how do you slow down? So we have disc brakes, and you have these brake pads that squeeze the disc brake, and it works very effectively. But after a while, you have to replace your disc pads, right? Your brake pads. And so those don't just like magically disappear. They actually are going into the air, the little rubber brake pads. And that's going into the air, which ends up in our lungs, and that is not good for our health at all. But we've just decided, since we can't see it, or like nobody thinks about it, it's totally fine. And that is a problem that we've just decided we're not going to solve right now. Also, when you explode things, they sometimes catch fire. Makes sense to me. And so there's been a lot of work done to make the internal combustion engine just not have this problem as much, but it is definitely a significant problem. I forgot the stat, but there's like, I think it was 150 car fires a day in the United States alone. Yeah, there's a lot. And then here's the one problem that should have kiboshed everything. If everything else wasn't a problem, this last sustainability issue should be enough of a problem for us to say, we got to change something. We've got to stop doing this. Because sustainability is, we've just decided we'll just pump more of that dinosaur juice out of the ground or whatever. It's actually, I heard recently it's not dinosaur juice, it's something else. But we'll pump out that gas out of the ground and put it into our cars and let that get into our atmosphere and kill our planet. So I guess that is just an unsolved problem. And so you all know where I'm going with this. This is the fastest mass production vehicle motor in the world. It's the Tesla Model S Plaid motor. And electric vehicles eliminate or drastically reduce all of these problems. Exhaust, totally eliminated. You do not have exhaust with electric vehicles. That's great. That's awesome. So not only is it not getting into the cabin, it's also not going out behind us and killing people who are riding one wheels. I hate driving or riding behind cars. It just smells so bad. Stopping also has been drastically reduced because electric motors are able to take that kinetic energy and turn it into electricity and put it into the battery. So I actually do have a Tesla, and we have this thing called one pedal, what do we call it? One pedal driving, where you just press on the accelerator when you want to go and lift off when you want to slow down, and it just sticks that kinetic energy right into your battery. I rarely touch the brakes. Now, to actually stop, you do need to use the brake pads, so there are still disc brakes, but I probably will never need to replace my brake pads, ever. So that's great. The problem isn't completely eliminated, but it's drastically reduced, and I think that's a great thing. Car fires, I know that when an electric vehicle catches fire, it gets like all of the news coverage because everybody's like, batteries catch fire, see, look at this. You're 11 times more likely to get in a car fire if you're driving a car that uses explosions to propel itself. That is a fact. So yeah, batteries, battery electric vehicles do not catch fire nearly as much. Because they're not using explosions to propel themselves. It's amazing. And then sustainability. Now this depends a great deal on where you're getting your electricity, but even if you're powering your vehicle by a coal plant, within a decade, your electric vehicle is better for the environment than an internal combustion engine. And I recently got solar on my roof, and so as I'm riding around in my Tesla, I'm going around singing, I'm driving on sunshine, whoa, and I'm so excited, like, yes, this is the future that we're going to, and it's so awesome. So Tesla is actually a really awesome, I'm kind of getting ahead of myself, sorry. Tesla is a really awesome case study for problem elimination. And so if you're ever interested in seeing some really amazing problem elimination in mass manufacturing, go check out Tesla's. And full disclosure, I'm definitely an investor in Tesla. If you research them as much as I do, you'd be a fool not to be. Yeah, there's your disclosure because people seem to care about that. Okay, so let's talk about our problem tree again. So with problem elimination, our tree looks like this. Here's the change. So we haven't just ignored the problem, we are solving the problem, we're just changing our approach to the problem. So instead of solution 1B, we went back up our problem tree and we changed our approach to solution 1D, and now we have hopefully a smaller problem tree. That's what problem elimination is. It's basically trade-offs. So let's talk about software now, because we're all software devs trying to solve problems in software. And the first example I want to use is React. React is great at problem elimination, in particular hooks. I love hooks so much. So let me talk about why. I started using React during like around 0.9, or yeah, 0.9. So that was back with like create factory and create class. And then we moved into class components, and now we have function components, and now everybody's confused and stuff, I guess. Just use function components, use hooks, stop using classes. There it is. So with classes, one of the, I actually felt pretty good about things. We have our life cycles, they're very clear exactly what happens when, and it kind of reduces the amount of time I spend thinking about time when I'm building my UIs. But code reuse was a real issue. And so we came up with, the reason that code reuse is an issue is because you have a concern like, I want to draw a chart, or I want to update the document title, or I want to subscribe to this pub/sub API. And that concern needs to be spread out across the lifecycle methods. So you have component did mount, component did update, component will unmount. And you have code in each one of those for that one concern. So when you have a concern and you want to reuse that concern, then you want to put it in like a function or something. But you can't do that because the bits of code for that concern are spread across these life cycles. So what did we do? Well, Sebastian Mark Bugge, I think is how you say his last name, he introduced this idea of higher order components, where it's a function that you call, and then it returns a component that does all of that stuff, and it just kind of wraps your component. And so the higher order components was okay, extremely difficult to type if you're trying to maintain a code base, and so you're using a typed language, TypeScript. And also had some limitations because it's just static. You're like creating a component that has to happen it can't happen within the render body. And so that's a big pain as well. And so we brought in the blue screen, and that solved all of our problems, or created problems. Yeah, we've eliminated my slides. And boom! Hooray! Yeah, when I get my M1 Max chip, this won't happen. Eliminating problems. It's in like 2 weeks. I can't wait. So yeah, and also you had, like, with higher order components, you'd pass on any state or anything via props to the underlying component, and so you can have prop name clashes and stuff. It was just a big pain. We didn't like that. And so we started doing render props. I think React Motion was the first library to introduce the idea of render props years ago. And this was cool because you could do it within the function body of your render method, but you ended up with like a big pyramid of doom if you were using a lot of them, or you could also have a false hierarchy where you're like, I'm not sure which component to use first in this pyramid of doom. And yeah, I thought it was awesome. And I recognize these problems, but I'm like, this is as good as we've got, and it's actually not that bad. There are workarounds for these problems. The React team, though, they were like, yeah, it's all right, but what if we look at our problem tree, and instead of trying to solve the code reuse with classes, we just go up a level, and we'll keep going up a level until we come out with hooks. And so now we have these hooks that we can use effect, for example, or use state within the body of a function component. And when we can do that, then all of the concern is contained in one block of code here. My son is calling me right now. He has this little watch, and I think it's school time. He wants to say goodbye. I love you, son, but I'm hanging up. You have all of this code right in one spot. And so now it's not a matter of how do I reuse code in React. It's a matter of how do I reuse code in JavaScript. Well, that's nice. I can just reuse code in Java. I'll take this, and I'll put it into a function, just like I do with anything else. That was brilliant. And they've eliminated a ton of problems that we had with class components, not just reusability, but that's what I'm focusing on right now. I am a super fan of hooks, and if you're not, let's talk. I'd love to talk with you about it, because it is brilliant. There's a reason that lots of other frameworks are borrowing the same idea. Okay, if I'm a super fan of hooks, you ain't seen nothing yet. Remix is the next big thing. I love it so much. And so to give you an idea of what Remix is, well, everybody here knows what, probably, most of you know what Next.js is. Remix is basically a replacement for that. And so that kind of puts Remix in your mind where it's supposed to be. I spent the last year working on an update to my website. And to give you an idea of what that is, just because I want to, well, mostly because I paid a lot for this video, I'm going to show you a video. So let's watch this video. So that is ConnectTech2021.com. It's a real app. It's over 27,000 lines of code. I worked on it with a team. I did like clearly most of it, but I had somebody help me implement designs. We had a designer and everything. So it's a real thing with users, and we have some really cool app experiences like recording in the browser, creating a podcast and publishing that podcast, all automated through my website. And in the process of building my website, Remix is what got me thinking about the idea of problem elimination. Because I felt like, as I was using Remix, that so many of the things that I was constantly thinking about when I was building web applications, I didn't have to think about anymore. It's been awesome. So I'm going to give you a rundown of a couple of the things that I've been thinking about, and I'm speaking later to give a deeper dive on like how things look and everything later as well. So if we finish here and you're like, I want more, well, you can have it. Also, I have about a bajillion stickers out on the table, the registration table over there. So if you want stickers, not just Remix stickers, but like so many stickers. Like this is Cody the koala. Cody has stickers. So yeah, go enjoy those stickers. Okay, so a couple of things I want to call out that we'll talk about a little bit. Nested routing. This React Router version 6 was just released. Nested routing, lots of what React Router version 6 is stuff that Ryan and Michael, who created Remix, also created React Router. They've been building in Remix. They put a lot of that stuff into React Router. And nested routing is one of those features. Seamless client and server interaction. I'll go into depth about this. It's just eliminates a lot of problems. Like, how many of you are using GraphQL? That's actually fewer than I expected. Well, how many of you kind of want to use GraphQL? That's more than, but still less than I expected. Well, that's okay. I'm going to show you why it's okay if you don't need GraphQL. You can use it, but you don't need it with Remix because a lot of the problems that that people want GraphQL for aren't really a problem in Remix. Remix is also very firmly based on the web, and I'll show you why that's so cool here in a sec. And really awesome mutations API that we'll talk about, and then CSS loading and unloading, and that's more profound than you think, and I'll show you why. Okay, so one of the biggest things that I love about Remix is the client and server bridge that Remix gives you. So when I have built apps, I've built apps for millions of users all over the world. When I was at PayPal, we had millions of users constantly always using our apps. And I had the server side and client side, and I always felt like there was this giant gap between the server and the client. And Remix does a phenomenal job of bridging that gap so I can be really effective as I'm working through things. This is one of the things that I love about Remix. So I'll give you a really simple example. That might seem a little trivial, but then I'll give you a more concrete example. So the thing about web development is that I've always felt like I was saying no to features and ideas, right? And we have all experienced this. The PM comes to us and says, hey, I have this like 3-day feature, and you're like, LOL, that's not a 3-day feature. I've got to like rip out our entire solution for this and put something else in. And that will always be a problem in software. We'll always underestimate how much work it takes. However, I feel like with Remix, I can say yes a lot more often. And here's a very simple feature to demonstrate this. So when you sign up for an account on KenCDodds.com, which I recommend you all do, go to KenCDodds.com/login, enter your email, you get a magic link, and then you get to this page. And feel free, so you can test it out and see if it's like really that good, right? So when you land on this page, I want you to be able to select a team, but I don't want to give preferential treatment to any of the teams. So I randomize it. So you'll notice I'm clicking the refresh button, and it's different every time we land on this page. The problem with randomizing things in a server-rendered app is if you do that within the component, then you could have one order on the server and then a different order when it's hydrated on the client. And this is not good because the server will render this HTML, the browser will load it up, and then when React hydrates, it'll change the order for the user. It doesn't look good at all, and React even warns you in the console when something like that happens. And so, yeah, we don't want this. And so normally on a small feature like this, I'd just be like, it's not that big of a deal. I'll just do it in my order. Or maybe I'll change the order every time I do my SSG build or something like that. But with Remix, it's actually really simple. So with Remix, we've got this loader function that we can create all of these values, and this only runs on the server. And when the browser comes and says, hey, I need this page, Remix is going to call this. We're going to shuffle the teams, and then it's going to render our new account component, and it's going to give us those teams in that order. And then we can render those teams in that order. And then when the client hydrates, that data is exactly the same, and so the hydration value is the same as well. And so this is why I say, like, simple features, even the small ones, I feel like are like, oh yeah, sure, that's easy. Whereas before, I would just say, here are my teams in the order, I just render them right here. It's a simple matter of scrolling up a little bit, putting it in my loader function, and now I can do the exact same thing, but I can have it randomized, or I can read from a database, or whatever I need to, without having to add a use effect anywhere, which I expected cheers for that, but no, just kidding. It's brilliant. Here's a more like a bigger example, and this is where we get into the GraphQL bit. So on the Chats with Kent podcast, I have all of that on my my website, and the API that I'm interacting with, or my podcast host, is Simplecast, and that API sends a ridiculous amount of data, like so much stuff. Yeah, I see nods. Anybody who's worked with that API, like, wow, they really want you to build stuff. But I guess they don't expect anybody to send that to a client, because that would just be ridiculous. It's way too much stuff. And so this is the point where people are like, well, let's use GraphQL, right? Because then we can just like say exactly the fields that we want, and we never have data overfetching problems. Well, with Remix, that wouldn't be your first thought, because your first thought would be, in my loader, I'll just write this little function, get season list items, that will go make that API call. I can even cache it if I want to, which I actually do, because their API is ridiculously rate limited. And I can filter out any of the properties that I don't care about. And so when I get back to the seasons, this is everything that I need in my app for the client, and nothing more. And if I need to make any changes, then I can just simply update this get season list items. I don't need to make any sort of request to anybody to say, hey, could you update that API or whatever, because we're overfetching. Or we're underfetching, now we need to get more. I can do all of that on the server side. And then here I send that along, and I can add a cache control header very easily. This JSON function is just a utility function for creating a response object. And so I can set my headers so that as users are navigating around really rapidly, they don't even need to bother making additional requests. And so it all feels super snappy and fast. And then in my component, I can just say, here, grab me my loader data, and now I've got it, and I can render that out. So we don't have the problem of data overfetching or underfetching, and if I ever need to make a change, it's all just like go into that function and add or remove properties that I need or don't need. And I never worry about data overfetching and underfetching. You can totally use GraphQL. I could use GraphQL if I wanted to right here, and still get all the type safety and everything. I get type safety with this. But you could get that through GraphQL if you want to. But the really cool thing about this is you can use your GraphQL, but not send an enormous GraphQL client to your users. Which, like, have you looked at how big that thing is? You think React is big? What? GraphQL is enormous, and it's awesome. It solves an enormous problem. But if we back up a little bit, change our approach, then we don't need the solution, right? And as great as that solution is, and as real as the problem is, if we change our approach, then we're not on that problem tree anymore. And so we don't need the enormously awesome, but very complicated solution. So another thing about this is you might notice that I'm not doing any pending states. And I'm not going to show you an example of a pending state right now. It's actually pretty simple. I just didn't have it on here. You can look at my website, and if you're like navigating really, really fast, then you might notice the pending UI that I've got in there. But the other thing that you need to think about is error states. And I'm not worrying about error states in my component either. Instead, I have this nice declarative API with Remix where I say, hey, Remix, here's this route, and here's the error boundary. So if there's an unexpected error, then that'll go into my error boundary. And nested routing makes this really cool. I'll show you that in a second. But I can just manage all of my error states just directly in my error boundary. So if for some reason I'm not using TypeScript or something, and so I don't realize that seasons is an object that has a seasons property on it or something, and so we blow up right here, that's going to land right in my error boundary. So I never need to worry about whether or not my seasons is available, because if it made it this far, then the request was successful and we're good to continue. The other cool thing here is that I can actually, there are sometimes planned exceptions, like 401, user doesn't have access, or 404. And so for those planned exceptions, you can say, hey, if there's no season, then let's throw this response. And then down here we have our catch boundary. And we can say, hey, you're trying to access the season that doesn't exist. I'm throwing this response. And so what's really cool about this, like you might be like throwing a response, like some of you might be like, oh yeah, that's easy. Like suspense throws promises. I can throw anything I want. But what's cool about this is Remix will catch this response and then it'll render a catch boundary. But what's really cool about this is it means that Remix is very abstractable. So I can take this code and I can stick it in any function anywhere, and it can be like really far down in my call stack. And somewhere in that utility I say, oh, they don't have access. Let's throw a response, and that will bubble up and it will stop execution of the rest of my loader. And so, like, you can there are already libraries that are like a Remix auth library. There's a bunch of utilities that use this API for these sorts of exceptions. And then I can just manage all of those exceptions in my catch boundary. I say, oh, if it's a 404, then I can say, hey, you're accessing a season that doesn't exist. So the nested routing comes in really nicely here as well, because here's my 500 or my error boundary component. And you'll notice that like I still have access to everything else on the page. I can still say, oh, well, chats 4 broke, but maybe season 3 will work, and I can click on season 3. But nothing in here, I didn't like give you all the JSX, but I am not rendering the season 4 or that tab list or anything. I only care about the part that matters right here. That's all that I care about, because nested routing enables me to just focus on the part of the route that I represent. We'll talk a little bit more about nested routing, but that is awesome. The catch boundary is the same thing. It will render right within the part of the route that we care about. It's brilliant. And if you want to dive deeper into this, come to my talk. Okay, so next, use the platform. I made this GIF to send to Ryan when I realized how awesome Remix is. This one too. Remix is amazing for using the platform in progressive enhancement. You know, use the platform was a hashtag that, I don't know if it started like this, but it kind of became this thing where people were making fun of React because, like, why are you doing all this stupid stuff with JavaScript? Just use the platform. And now I'm using React with Remix, and I'm using the platform better than most of those people who are making fun of us, because Remix just does this really well. So, first of all, everything with Remix is with web APIs. So you're using fetch on Node as well as in the browser. You're using regular request response headers, like everything. There are a couple of really cool things about this. For one, if you have a question about how do I do such and such thing with Remix, the answer is not in the Remix docs. The answer is on MDN. Well, that's cool. And so one of the things I love about React is the better I get at React, the better I get at JavaScript, because they go hand in hand. React is pretty much, like there's the JSX stuff that some people don't like, I guess. I love it. But once you learn that, everything else is just JavaScript. And I freaking love that. I think that's awesome. Coming from another framework, and I had to just say goodbye to everything that I'd learned about that framework. I did not like that. And so what's really cool with Remix is the better you get at Remix, the better you get at the web platform, because they're based so solidly on web platform APIs. I love that about Remix. The other really cool thing about this is that Remix is kind of like the jQuery for platforms. And so they will normalize your platforms across, like whether you're deploying to fly.io, which is where I deploy to. I love it and it's great. Come talk to me about it. Or if, and that's just like a Docker container. Or if you're deploying to Azure or Vercel or Cloudflare workers, which it actually does work in Cloudflare workers. So like new hotness, that's exciting. You can deploy Remix to Cloudflare workers. Compute on the edge, it's so fast. And Remix just normalizes all of this stuff for you. So provided that your code and your dependencies code could run in all of those environments, Remix will just make it work, and all you have to do is change a dependency, and your app will work in any one of those environments. That's cool, and it's in large part because they just we'll just normalize across the fetch, request, response, headers, all of that stuff. Oh, and also because it works on Cloudflare workers, Remix will soon work in a service worker, so you can have a completely client-side app with Remix as well, which is kind of interesting to think about too. Okay, so then another cool thing is the form. So this is the progressive enhancement bit. So let's say that you've got a list of items and they've got a little trash can icon next to them, and so you click on the trash can to delete that item, right? How would you implement this? The way I would do it before Remix is I would say, okay, let's wrap that trash can icon in a button. On click inside of the handler, I will either set state and then have a use effect that does a fetch if I care about race conditions, which you probably should, and so that's probably what you should do. Or I would just be lazy and I'd do the fetch directly in that click handler and then hope that race conditions aren't a problem. And then like have to manually update my cache and all that extra other stuff. I'd probably use React Query, to be honest, because React Query is awesome. But with the problem with that is if I am a user on a slow connection, I not only have to wait for the HTML to download so I can see everything, but I also have to wait for the JavaScript to download so I can actually click that delete icon. Well, with Remix, this is not a problem. This problem is eliminated because with Remix, you wrap that in a form, their form component, and their form component renders to an actual form as a HTML element. And so if the JavaScript is still downloading while I'm trying to interact with this, I will click that button, and it will do what the browser has always done since like forms were invented years and years ago, and it will do an actual full page refresh delete request to that action URL, and everything works. So you've got, I talked about the loader before in the Remix module. You also have an action for non-get requests. And so when you hit that form, it's going to do an actual action, and it will hit your action code, and everything will run exactly as if it had been a regular fetch. And so that's progressive enhancement. That's what it is. It's my app works, and it gets better as the browser has more features or we download the JavaScript. And then, of course, if I don't manage to hit that delete icon before the JavaScript loads, then we can actually hit it. It'll be not a full page refresh. And Remix also will manage all race conditions and everything for me. So again, you don't need to worry about use effects at all. You just like, here's my form. It's very declarative, mutations API, and now I can proceed with the rest of my life. It's so great. The last two bits about this is the link tag. So I pretty much have only ever used the link tag for loading CSS and that sort of thing. Remix uses the link tag a lot for preloading modules as the user's navigating around and preloading even data as the user is navigating around. So if you go to my website and you go to like hover over the workshops, it will preload all of the JavaScript, CSS, and data for that route, so that when you actually click on it, it's already in the cache and it navigates instantly. This is really cool. This is really cool because it means that if you decide, hey, well, let me take a step back. For most of us, or at least for me, in my time as a JavaScript engineer, I'm shoving everything into JavaScript as much as I can because I love JavaScript and it's awesome. And so what I would do if I were to implement this is I would say, okay, go. They're hovering over the link, so let me go grab that workshop data and I'll stick it in my in-memory cache with React Query. And that's great. But what if the user hits command click? So they're opening a new tab. Well, whoops, like that in-memory cache is totally gone. That new tab is having to load it all by itself. So you can do a lot of really cool optimizations if you use the platform. And Remix does that really well. So I love Remix for that reason also. Okay, CSS, let's talk about this. I've been using CSS for a long time. I started with like spaghetti CSS, and then I used BEM, and then I've used preprocessors. I made my own version of Tailwind like way before it was cool. Like Stylus was really awesome. You could do some really cool things with it. I had like P-1, P-2, like all of that stuff. I did it, but I don't get credit for it. No, just kidding. They did way better, and it's amazing now. But yeah, so I went through that. I also did CSS modules. That was like mind-blowing. I did CSS and JS. I built a CSS and JS library, Glamorous. Anybody use Glamorous before? No? Ah, yes, thank you, Sia. And John, thank you. Glamorous was like the thing before Emotion. And then one of the contributors to Glamorous was like, there are a lot of problems with Glamorous. I'm going to write my own thing, and that's what Emotion is. And I was like, sweet, You maintain it. I deprecated glamorous. That's why none of you have heard of it. So like, I went through all of that. I've been through it all. I've done it all. Let me tell you, skip to the end. It's Tailwind. Just use Tailwind. It's great. Come, feel free. Yeah, applause is welcome. But feel free to come talk to me about it later. But Tailwind's awesome. If you're not super into it, or if you have a couple of pages where you're like, oh, we just want to do things a little bit differently, Remix has got you covered. So all of these solutions that we've been working on for all of these years, the primary motivation behind these solutions is, how do you know that a change in your CSS is not going to impact other places that you aren't aware of? And this is the reason why on my team at PayPal, we had 90% unused CSS. I'm not joking. Go pull up the coverage, the CSS coverage in your DevTools, and click around your app and find out how much unused CSS you've got. Because unless you're just 100% using styled components or something, that solution, right, was built for that problem. If you're using any global CSS, you have this problem. And so that's why we use CSS and JS. But there are a lot of problems with that. That's your solution node, but then you've got a bajillion problems off of that as well. So Remix has taken a different approach. They went up the problem tree, and here I've got an H1 on the page that's styling this to be blue. At least that's what it looks like on my screen. And you'll notice we've got this about-hash.css file. And when I click on the header to go back to the home page, that is removed. So, and you'll notice that the H1 is no longer styled blue. So I literally, that file, it literally has H1 color blue. And when I navigate away, H1 color is not blue anymore. And this is the matter, it's so simple. I was frustrated. I was angry that it was this easy because I've been struggling with this problem for so long. But the solution is, if you don't want the CSS to apply, then remove it from the page. And so in Remix, you import the styles, and then you have this links function that you export that you say, here are all the links that I want on the page when this route is active. And when the route is not active, they're not on the page. And so you can, what's so profound about this is you can say, okay, so I'm in this about.css file, and I can do whatever the crap I want in this, anything, whatever, style spans if you want to, anything you want to. And all you have to do is find all the places where that CSS file is included on the route. And in practical terms, that's going to just be on this one page. And as long as that page looks good, you don't have to check anything else. This is great. I love this. Now, again, I say just use Tailwind. It has really great conventions and awesome constraints that make my UI consistent. But if that's not going to work for you, or if you just need to do a one-off thing, you don't need to reach for a CSS and JS thing. Like I said, CSS and JS, great. It's awesome. Vanilla extract seems really cool. But I don't have the problems that those things solve. And that is awesome. Thank you, Remix, for problem elimination. Okay, so with the last little bit, I want to show you this example of this UI. So if we're building this sort of UI, we've got this header, we've got a list of items, and then we can click on each one of these. If this were the UI you're building in Remix, then you would have the whole main app is for the slash. That's the slash route. And then this bottom part, all of this is going to be the user's route. And then the last bit right here is the user ID portion of the route. Okay? So these are 3 routes. This is nested routing. It's amazing. And so because of the way that this is structured, Remix can do a couple of really cool optimizations for us. For one, your loaders all run in parallel. So the root route is going to load some data. And then for the header, it'll render out the header. And then it just renders an outlet. This is in React Router version 6. You have this outlet component. And so you've got your header, and then you say, everything else, all my children are going to go here. And then the user's portion is going to go load some data for just the list items. So you don't need all of these or data, just enough for what you're going to show the user there. And so we'll render that on the left, and then we'll render an outlet here on the right. And then the user ID is going to go load the details for that user and render out its stuff. Each one of these things only cares about its portion, as well as rendering an outlet for where its child should go. So all of the loaders can run in parallel. That means faster, right? Parallel is good most of the time, so long as you have enough cores. So then Remix loads only what's needed. So as the user's navigating around and they click on this next item or whatever, Remix knows that the only part of the page that needs to change is this child route right here for the user ID, So it doesn't need to bother reloading this list or reloading the header or any of that stuff. It just reloads what's needed. Mutations will trigger invalidation of all the loaders. So if you make any sort of mutation, you don't need to worry about the cache. Remix has got that handled, and it also handles all race conditions and everything for you. You don't think about it. And if you are interested in this some more, come to my talk later. And then context for shared UI state and remix for shared server state. So like people, you might ask, how do I use Redux with remix? And my response would be, why would you ever want to do that? You have like 6 items of state that you need to manage because everything else is just built into remix. Now I have my call recorder and I use xstate for that, but it's scoped to that component, right? So it's totally fine. So state management is not really a question with remix. They've kind of eliminated a huge category of problems there too. And then, of course, no layout component. Anybody who's used Next or Gatsby knows what I'm talking about. And if you don't know, that's great. OK, so yes, do come to my talk later to talk more about remix. But just to circle it back in, problem elimination is all about trade-offs. You're just making trade-offs. The idea is that you want to eliminate big problems in exchange for smaller ones. So in conclusion, solving problems is great. Please don't stop solving problems. Please, the world is a big problem that we're all trying to solve and make better. But if you can, see if you can eliminate problems first. Take the solution you're working on. It's really hard. Back up the problem tree a little bit and see if you can take a different approach to trade off for smaller problems. And if you can do, before you even try to do that, try to avoid the problem altogether. There's a limited amount of minutes in your day. Try to spend those minutes working on the most important problems. So if you can't avoid a problem, try to eliminate it by changing your approach, and only if that fails, then you can solve it. Thank you very much.